Let's look at location. Locations of earthquakes are typically along plate boundaries. You're going to see that all over the world, particularly the Pacific Ring of Fire, they call it, the area around the Pacific where lots of volcanoes occur. This is where we have lots of subduction, and you're also, of course, going to have large earthquakes. So on the Pacific Rim there. You do get minor earthquakes through the divergent boundaries of the world, the Mid-Atlantic Ridge, the East Pacific Rise, among others. And then, of course, where continents collide, that continental-continental collision, you're going to get pretty decently sized earthquakes all along the Alpine Himalayan belt here, where there's lots of continental collision taking place. Of course, the San Andreas Fault in California gives us some strike-slip motion, along with the North Anatolian Fault in Turkey. But there are many areas of the world that experience earthquakes. Most of the earthquakes occur along plate boundaries, but I did want to mention that there are some mid-continent earthquakes. For example, mid-continent China. What you're looking at here is a picture of India, and as India slams into Asia, you get the buckling up of the Himalayan mountains. Obviously, there's going to be earthquakes along there. That's a continental-continental convergence. But when we talked about mountain building, we talked about how the back of that area also buckles up to form a plateau. And so the Tibetan Plateau, extending all the way through the central region of China here, also happens to be in the area where some of the most populated river valleys and really most fertile farmland is in the entire world. And so right along this area here, where you have all these very densely populated river valleys, you also get pretty strong earthquakes. That recipe is for disaster because the more people you concentrate into a very dangerous area, the deadlier it is. So they've had some real problems with deadly earthquakes in mid-continent China. In fact, the deadliest earthquake in recorded history was in 1556 in Shanghai, China, which is also in this region, 835,000 people killed. There is also mid-continent earthquakes in the central part of Illinois, southern Missouri, Kentucky, Tennessee, northern Arkansas. There's a fault zone called the New Madrid Fault Zone after New Madrid, Missouri, where there were large earthquakes in 1811 and 1812 over the course of 3 months. By large earthquakes, we're talking 7 magnitude earthquakes, even some estimates of 8 magnitude earthquakes. And we think that these earthquakes are caused by what's called the Real Foot Rift. If you take a look here, you can see Missouri, southern Missouri, northern Arkansas, Tennessee, Kentucky, Indiana, Illinois. This Real Foot Rift and accompanying fault lines is thought to be the cause of this. You can see that there's kind of some tectonic activity and magmatic activity where magma has intruded upward, causing the crust to melt a little bit and shift and start to buckle down. And as a result, there's been pretty significant shifting there. We think that this rift is possibly stalled, that it's not currently active or producing magma, but nonetheless, it did cause some pretty big earthquakes. And of course, the whole area is regionally compressed, so that also causes and helps faulting in there. So that's intensity of an earthquake. As far as locating an earthquake is concerned, I'm sorry, that's generally where earthquakes occur, where you have plate boundaries and even in mid-continent earthquakes. If you want to actually locate the specific epicenter of an earthquake, you can go no further than the seismograms. Pictured here in the upper right is a seismogram with the P and the S waves, noting that they arrive about 3 minutes and 45 seconds apart from one another. We talked about how the P wave is faster than the S wave. It's actually 1.7 times faster than the S wave. And incidentally, because we know how much faster the P wave is, if we know how far apart they arrive, we actually know how far we are away from the epicenter. And there's a graph that you can create to graph the P wave distance over time. And you can also graph the S wave's distance over time. And when you take a look at those two lines, the difference between them in our example, 3 minutes and 45 seconds, when you find the difference of 3 minutes and 45 seconds between them, you can actually tell how far you are away from the epicenter of the earthquake. So a seismograph feeling the earthquake waves coming in, the P wave, and then 3 minutes and 45 seconds later, the S wave. What you can determine is how far you are away from the epicenter. If we were to actually graph this, say our seismograph is in Columbus and we determine we are 2,250 kilometers from the earthquake, we can draw a big circle around Columbus and say, hey, the earthquake occurred somewhere around this circle. Now, this method is called triangulating because you need two more circles for a total of three circles to actually pin down the location. If we in Columbus call up St. Louis and say, hey, St. Louis, did you feel that earthquake? And they said, yeah. The P and the S wave arrived about 2 minutes apart, and it's about 1,000 kilometers from us. So we draw 1,000 kilometer circle around St. Louis, and we narrow down the earthquake to either occurring right there or right there. The last thing we do is call Memphis and say, hey, Memphis, did you feel it? And they said, yeah, it was 500 kilometers from us. So we draw that 500 kilometer circle, and bada bing, bada boom, they all three meet right there. That's where the earthquake occurs. So locating an earthquake is as good as finding the seismograms from three different seismograph stations and finding out how far you are away from the earthquake. This is how we locate the earthquake epicenter. Lastly, earthquake damage. Of course, seismic shaking does a lot of damage. The surface waves, the Love and Rayleigh waves that emanate from the epicenter of the earthquake cause a lot of damage. An example seismic intensity map shown here. We saw one earlier as well. But there are other things that are caused by this shaking. For one, landslides. When shaking occurs, vulnerable slopes and weak slopes have a tendency to fail, and they can kill lots of people. This picture is from an earthquake that occurred in El Salvador, and it was a 7.1 earthquake, but most of the deaths occurred because of this big landslide that happened that after the earth started shaking. Liquefaction is also another danger. And what happens here is that if water is soaked into sediment and the sediment is wet, when the earth starts to shake, the water collects around each of the grains and causes the grains to flow. So if anything heavy is above, it's going to shift or even sink into the sediment. You can see pictured here a truck that has happened to. And then, of course, fire. Fire occurs during earthquakes because gas mains break from the shaking, power lines are down to create a spark, a fire ensues, and firefighters come to put out the fire, and the water mains are broke, so they don't have any water to put out the fire. So fire can be really devastating. The 1906 San Francisco earthquake saw fire damage 90% do 90% of the damage done. 1920, 1943, I'm sorry, 1923, Tokyo, Japan, an earthquake occurred. A very large earthquake there, but a good amount of the deaths, over 30,000, were due to fire. A good amount of those deaths were due to fire, and it can be a really bad disaster during an earthquake. A little video clip here we'll skip through. And the last one here that I want to talk about is tsunami. Tsunami can be very devastating in an earthquake. As it turns out, lots of earthquake deaths occur because of this. An example I would use for a tsunami is the earthquake in December of 26 of 2004 in Sumatra, Indonesia. Large 9.0 earthquake, one of the largest in recorded history, actually hit that area just off the coast. And what happened is because the earthquake occurred underneath the sea at a subduction zone, much of the earth that popped up due to that subduction zone style earthquake caused a tsunami, and the tsunami waves raced across the ocean. There were five major waves through that tsunami. No set wave is the largest, but particularly for this one, the fifth wave was the largest. And it came in, and each of the waves washed through back the sea before they hit. You can see the picture of the draw down there where the sea pulls back, and then the run up is where the water washes forward. It picked up debris that slammed into other debris, and eventually the water just took the debris inland and buzzsawed the entire landscape, killing people, destroying everything, leaving a complete disaster zone. Um, One of the things I guess I would get across to you is that if you're ever on a beach and the shore of the sea pulls way back, or if you feel an earthquake, if for that matter, you don't want to wait for the shore to pull back. to tell you that a tsunami is imminent, you need to get to higher ground immediately. So tsunami are very deadly, and they're part of underwater earthquakes. Here's a look at along the Indonesian frontier. This subduction zone here is where the earthquake occurred. This stretch, huge stretch of 1,200 kilometers of fault slid all at once 15 meters, and it popped upward, sloshed the water upward and outward, and devastated the entire coastline. So here's a little picture of the before and after of the damage. Before on the left, after on the right, you can see tsunami can completely wipe areas out. So that's a discussion of earthquakes from the characteristics and causes, the elastic rebound theory, the focus of the earthquake where the slippage occurs, the epicenter where is the area right above that focus, seismic waves in the form of P and S waves traveling through the earth called body waves, disturbing the surface to cause surface waves in the form of Love and Rayleigh waves, noting that a seismograph is the device that records seismic waves. The seismogram is the record of the seismic waves. The magnitude of an earthquake is how strong it is, measured in moment magnitude nowadays, which is the amount of slippage, the area that slipped, and the rock strength near the slippage. Intensity being the strength of the earthquake measured by the damage done and what was felt. And then locating an earthquake, noting that most earthquakes occur along plate boundaries, but there are some mid-continent earthquakes. We noted in China and even in the US, and that you can locate an earthquake epicenter by using the difference in arrival time between the P and the S waves. Damages done by earthquakes can be devastating, not only the seismic shaking and building to collapse, but things like landslides, liquefaction, fire, and tsunami. And so I hope you enjoyed learning about earthquakes. I wanted to give you a overview of this last set of topics. Since I'm not present for the lecture, you can still get a sense of what's happening here with the last part of earthquakes. So take care, everybody. Talk to you soon.